suppose a standard six-sided die is rolled and you receive $4 for every dot showing on the top of the die. What should the cost of playing the game be in order to make it a fair game? Okay, so what they're really asking on this question, a fair game. What is a fair game? A game is fair when the cost equals the expected value. That's a fair game. When what it costs to play the game is exactly equal to the expected value, or the average, that's the same thing as average dollars the game is going to pay you. So when it costs, what they charge for you to play the game, if that's exactly equal to what on average you get from the game, that's what we mean by a fair game. So to figure that out, the cost has to equal the expected or average value. So really then this becomes a question of figuring out what is the expected value of this game. Remember how we figure out expected value? You take outcome number 1, you take the probability times the value plus outcome number 2, the probability times the value, etc. So for each possible outcome, each possible thing that can happen, you figure out the probability and multiply it by the value, the money. So what are the different things that can happen when a six-sided die is rolled? Well, you could roll a 1, or you could roll a 2, or you could roll a 3, or a 4, or a 5, or a 6. You could roll the numbers 1 through 6. Those are the only different things that could happen. Those are the 6 outcomes. So, for each of those, what's the probability? Right, first comes the probability. So that's going to be 1/6 times, what's the money? What's the value, the dollar value? Each of the values is dollars. What's the dollar value you'll get if you roll a 1? Well, you receive $4 for every dot. So if you roll a 1, there's only one dot showing, you'll receive only $4. Plus, what's the chance you're going to roll a 2? Oops, let me get rid of that. Chance you're going to roll a 2 is also 1/6, and in that case you'll get $8 because you'll get $4 for every dot showing. You got 2 dots showing, you get $8. Plus the chance you're going to roll a 3 is 1/6, and 3 times $4 for each dot, you'll get paid $12. If you roll a 4, 1/6 chance of rolling a 4, you'll get paid 4 times 4, $16. Plus the chance of rolling a 5 is 1/6, and 5 times 4, you'll get paid $20. Plus last, the chance of rolling a 6 is 1/6, and if you do, you get paid 6 times 4, $24. So there's what we have to figure out. So just take your calculator, take 1 divided by 6 times 4 plus 1 divided by 6 times 8 plus etc. Or you could just add up all the 4, 8, 12, 16, 20, and 24, and then just divide the whole answer by 6 because they're really all over a common denominator of 6. If that doesn't make sense, don't worry about it. And when I do all of that, I get $14. So what is that $14? It's the average or expected value. In other words, if you do this strange game they've devised here where you roll the die lots and lots of different times. Sometimes you'll roll a 1 and you'll get $4. Sometimes you'll roll a 2 and you'll get $8. Sometimes you'll roll a 3, you'll get 12, etc. All these different things will happen. If you do it hundreds and hundreds of times and you find your average will be $14. On average, what you should expect to happen on average, your average or expected value, is $14. That's the average amount. That's what casinos do. They figure out the average payout, just like we just did for every game, and then they charge just a little bit more. They would charge maybe $15 or $16 to play this game, knowing that they're going to pay you back $14 on average. So they'll be making a little bit of money each time you roll the die on average. That's how every casino game works. They for sure will win in the long run. It's all mathematics. They know they're going to win. So if you gamble, that's fine as long as you know you're going to give them some money. When you're in trouble is when you think you're going to win. That's when they've got you and they're going to take your house. And that happens to lots of people. So don't be that way. Be mathematically wise. Every casino game, they have calculated this exact thing we just calculated. And then they raise the price above it because therefore it's not a fair game. So for us, they asked what would be a fair game? The fair game would be if they charged exactly $14 to play the game, because we expect on average to make 14. So if they charged 14, that'd be completely fair. We would break even in the long run on average. But none of the games at the casino are fair. They're in the business to make money, so they raise the price above the fair price. So there we go.